There's a couple of really interesting stories around this week, both of which I want to have a chat with one of our tame astronomers. Dr. Alan Duffy is an astronomer from the University of Melbourne who also holds some interesting little drinking science nights at pubs in Melbourne. I've got him on the line. G'day, Doc. How are you?
How's it going?
Very well. Thanks for joining us. Now, a couple of things that I wanted to get across this week. The first one is that some astronomers from the University of Hawaii have managed to find a planet outside our solar system, but it's floating around in space and not orbiting around a star of any kind. Question: How? How does that happen?
Okay, well, first off, that's a great question. It was a surprise discovery. Stars form planets around themselves. Planets shouldn't form on their own. This is a big object. I want to make that clear. It's about 10 times the size of Jupiter.
Wow. Okay.
So it's not like you suddenly find something like the Earth. But even so, even something as big as that is still a lot smaller than a star, and it's really challenging us to explain how that can actually form on its own.
Yeah, or is it possible that it was somehow in an act of violence around a forming solar system somehow shot out? Get collided somehow with another fairly significant planet, and instead of merging in, or it's kind of whizzed off on its own. Is that possible?
That's absolutely possible. When planets form around stars, they tend to have a very violent sort of interactions, and some of these planets can be pretty jealous and can fling their siblings off into interstellar space. The problem about this is there's just nothing near this planet. It's really it's difficult to see even where it could have been flung from.
Okay, now just on my reading, it seems to have formed about 12 million years ago, which is the blink of an eye, even by Earth geological standards. So it's a particularly young planet. It can't have wandered too far from source in that period of time, could it?
That's it. That's why we're pretty confident that it seems to have formed on its own. 12 million years, you're right, it's a tiny, tiny age. It has formed in a region with some other stars all around the same time. So we think they've all formed together, but this planet really does seem to have formed separate to those objects.
Well, okay, so now we have to try and come up with a mechanism whereby a planet can form pretty much in the middle of nowhere with no star at its center.
Yeah, the theorists are going to have a lot of fun trying to
figure hell yeah. Which is why I wanted to talk to you, because if you don't know, then the chances of me being able to work it out are absolutely impossible. Okay, how would we begin to try and determine where this planet was actually formed, or from what, if it wasn't formed around a star?
So we can use powerful supercomputers. This is where you have a room just filled with PCs all strung together. And you can actually start to simulate little regions of space and watch gas form and collapse to form planets and stars. But as I said, almost all of our models show that this isn't what usually happens. So
okay.
We're missing something.
Right. So is it possible that had there been, I don't know what, more space dust, if I can use that, debris, matter from which this planet may have formed, if there'd been a whole bunch more of it, might it have collapsed into a star? Is that possible? Are we just dealing with not quite enough material here to generate a star?
That's right. This is it's so small it can't burn hydrogen in its core, the fuel for stars, so it doesn't shine. So we call it a failed star. And Jupiter is an example of that, although it's pretty puny by those standards.
Yeah.
So with a bit more mass, roughly about 10% the size of our sun, it could have actually shone. But the point is nothing forms alone. So even though we can't see it, we're pretty sure there must be planets orbiting around this planet itself, just like the moons orbit the planets in our solar system.
Okay. Is it therefore possible, and I'm speculating here, that planetary objects significantly smaller than this one may well be a whole bunch closer, but we just haven't found them yet because perhaps we're not looking in the right place, or as you say, there's no sun for them to reflect light back to us, so they're really hard to find, in other words. Could there be closer, smaller, rocky planets to the Earth that we just haven't discovered yet, that are whizzing around all by themselves?
Absolutely. I think it's quite likely that, as I said, the process of forming planets is pretty violent, and sometimes these planets come out the wrong side of an interaction with their larger siblings and get flung out into space. So
yeah, well, I guess that's a fortunate thing. Otherwise, we wouldn't have our moon, and if we didn't have the moon, we wouldn't have the Earth the way it is. So, thank God for those for violent beginnings to solar systems. Otherwise, we probably wouldn't be here having this conversation. Okay, look, the other one that got me, I don't know, arguably even more excited, to be honest, was what's been described as an autopsy has been carried out on a distant, broken apart planet that seems to have had Earth-like conditions. In fact, significantly more water by volume than the Earth has. That's an extraordinary discovery if it is accurate.
Oh yeah, this one absolutely blew my mind when I saw it in the journals on Friday. The discovery is that an object has crashed into a dead star, and this object had water. This rocky object had water on it, and about 26% of it was water, which is huge.
So what's the Earth from memory is something like 0.04 or something, isn't it? Percent? It's some tiny amount by mass.
That's right. You have the giant oceans, but they're just on the surface. The majority of the Earth is obviously rocky core and lava, and the core. It's altogether that's 99 plus percent rock. So we're actually a desert relative to this little guy when it crashed into its dead star.
So what would it have looked like prior to the collision?
Well, it certainly looked. It was about 100 kilometers across, give or take. So
it's it's not a large object by any stretch of the imagination.
No, that's right. It's the fragments of planetary formation. Forming planets is a fairly messy business. And in our old solar system, we have the asteroid belt between Mars and Jupiter.
Sure.
And there are some objects there that are comparable size, such as Ceres, to this little guy when it crashed into the star. So the pieces are there that this system, all these this huge distance away from us, could have looked something like our own solar system. And I think that's what makes this discovery so exciting, that you had liquid water.
Wow.
Well, you had water at least on rocky planets. And as far as we know, that's what you need for life.
Okay, now this one, I know we're talking some vast distances here, but it's still relatively close, isn't it? 150 light years away is just a little bit outside the neighborhood.
That's right, but the light year, the distance light travels in a year, is many trillions and trillions of kilometers. So it is all relative, but it's still a heck of a distance. Okay,
so we've found a whole range of things like magnesium, silicon, iron, oxygen, and a large proportion of oxygen, and that's where we get the clue about the water, isn't it?
That's right. This was a real detective story. You're not going to see water itself. It's after this object crashed into this dead star. It's a dead star, but it's still very hot. So what you have to do is figure out where does that oxygen come from. And anyone who's watched their car rust away knows that iron loves to bond with oxygen.
Oh yeah.
Iron oxide. So you add up all the iron and all the other elements you've mentioned. See how much oxygen they could have brought with them to that star and that little asteroid when it crashed. And anything left over must have come in as water, as H2O. And it turns out there's a huge amount extra. So this was, and as we mentioned, by volume, it was, or by mass, was 26% water. So really a fantastic amount of water.
It's incredible. I still find it astonishing, and I pinch myself that here we are having a discussion about a couple of planets, neither of which orbit around our sun. One doesn't have a sun to orbit around, and the other one held a whole bunch more water. But these are things that literally 15 or 20 years ago didn't exist in astronomy. But we've found what I think is 1,500 odd exoplanets under examination, or potentials under examination at the moment. And here we are performing spectroscopic autopsies on one that's been broken up, has a huge amount of water, and the other one is a thing 12 times the size or 10 times the size of Jupiter, off floating around in space all by itself without a sun, without a star in the center. I mean, it's just phenomenal the rate at which astronomy has gone ahead in leaps and bounds when it comes to the discovery of these planets that aren't orbiting our sun. It's amazing.
That's exactly right. It's phenomenal, but what impresses me even more, perhaps, than even this is the fact that just before I came on, I checked my exoplanet app on my iPhone.
Oh, yeah? Oh, is there such a beast?
Yeah, and honestly, it is amazing. It updates live as these exoplanets, these planets around other stars, are found.
Wow.
They get sent to your phone and they get painted onto this beautiful picture of the galaxy. And this is what a world we live in, that we can get this information so readily and share it with the public.
How come I don't have that app? What's it called?
Exoplanet.
Exoplanet. All right, I'm going to get that when I get off air.
Enjoy.
Exoplanet. All right, look, I appreciate your time, Dr. Duffy. Thanks so much. It's just a couple of really, really interesting stories in astronomy just out in the last week, and I appreciate your time and expertise tonight. Thank you.
Pleasure. Thank you.
Good on you. Dr. Alan Duffy, who's an astronomer from the University of Melbourne. He does interesting, you know how you do politics at the pub and all that kind of thing? You have a few beers and talk about politics. Well, he does a thing called Pint in the Sky, which is a similar kind of thing. In pubs in Melbourne, you go out and have a couple of beers with the boys and talk about, well, planets and stars and the kind of stuff we've been talking about now. But that is astonishing, isn't it? Really. When you were a kid, did you ever think that you would be hearing about or reading about planets that do not orbit our sun? As a child, I couldn't even have got my head around it. But then again, as you look up into the night sky and you see all those stars, I, even as a very small child, thought, I wonder whether there is somebody on a planet around one of those stars looking backwards and wondering if anybody's looking at them like I'm looking at them. Or, if they're looking back at me going, hey, is anybody looking at me? It is extraordinary stuff. I'm going to download that app for my phone. Exoplanet, it's called. That's what we call them when they're not orbiting our star, our sun. We call them exoplanets. So one there that's broken up, a very small one. It's rocky and it had lots of water on it, like the Earth. Only more water by mass than the Earth had. And the other one is the thing that's 10 times bigger-ish, 6 to 10 times bigger than Jupiter, and it's just floating around in space all by itself.